chain rule. If y is equal to f of u and u is equal to g of x are two differentiable functions of u and x, then a composite function y is f of g of x is a differentiable function of x, and dy by dx is d by dx of f of u is du by d by du of f of u multiplied by d by dx of g of x is dy by du multiplied by du by dx. That is dy by dx is dy by du multiplied by du by dx. Proof. Let x is changed by a small amount delta x, that is x is changed by a small amount delta x, this change in delta x will cause some change in u, that is this will cause u to change by an amount delta u. This is like that we have function, for example this is x-axis, this is u-axis, and we have function u is equal to g of x, like that. Now if we change x from x to x plus delta x, that is there is some change in x, small amount of change delta x, then there must be some change delta u along u axis, and this change in u will cause some change in y. This will cause y to change by delta y. This is because we have y is f of u, function y is f of u, and this is u axis, this one is y axis. If there is some change in u and then delta u, then there must be some change in y, that is delta y. There is delta y, and this is delta y over delta x, and delta y by delta u. Now according to this we can write delta y over delta x means change in y with respect to x. Delta y over delta x is equal to delta y over delta u, or delta u multiplied by delta u over delta x. Okay, this is delta y over delta x is delta y over delta u multiplied by delta u over delta x. This is delta y over delta u, and from here we have delta u over delta x, which is a slope of function, slope. Now by this is a, taking this is as a. Now by letting delta x approaches to 0, as we do is in derivative, letting delta x approaches to 0. This is as we do in definition of derivative, taking limit delta x approaches to 0. We force delta u to approach 0 as well. Means when we approach delta x approaches to, when we have delta x approaches to 0, automatically delta u approaches to 0, because delta u is equal to delta u multiplying and dividing by delta x. Now taking this limit as delta x approaches to 0 on both sides, we have, so limit delta x approaches to 0, delta u is equal to limit delta x approaches to 0, delta u over delta x multiplied by delta x. Now this implies limit delta x approaches to 0, delta x approaches to 0, delta u is equal to limit delta x approaches to 0, delta u over delta x multiplied by, again limit for this term delta x approaches to 0, limit for this term delta x, which implies limit delta x approaches to 0, delta u is equal to limit delta x approaches to 0 divided by delta u over delta x becomes dy by dx, multiplied by applying limit delta x approaches to 0 on this will become 0, which implies limit delta x approaches to 0, delta u is equal to 0. From this above we can say that limit a can be written as, from these assumptions, as delta x approaches to 0, then delta u approaches to 0, a can be written as limit delta x approaches to 0, delta y over delta x is limit delta u, here is delta u, therefore taking delta u approaches to 0, delta y as delta x approaches to 0, then we have delta u approaches to 0, delta u delta y over delta u multiplied by limit, since here is delta x, so delta x approaches to 0, delta u over delta x. So applying all these limits, we have dy by dx is equal to dy by du multiplied by du by dx, which is chain rule for two functions. Similarly, if we have 3 or more than 3 functions, then this chain can be extended easily. For example, if we have 3 functions, then this chain can be extended to 3 functions chain. Like if we have u is equal to y is equal to f of u and u is equal to g of v and v is equal to h of x, then this chain can be extended as dy by dx is equal to, means with derivative of y with respect to x is equal to dy by du multiplied by derivative of u with respect to v du by dv multiplied by derivative of v with respect to x dv by dx, which is chain for 3 function. And similarly, if we have 5, 4 or more functions, then can be extend